back to my YouTube channel. So let's continue with the intermolecular forces. In this part of intermolecular forces, we are going to discuss about London dispersion forces. So what is London dispersion force? Okay, it is actually significant only when molecules are close to each other. Okay, so the existence of London dispersion forces actually happen or present in all molecules, whether they are polar or non-polar. Okay, as long as they are close to each other. Okay, due to the electron repulsion, what we call temporary dipole on one atom can induce a similar dipole on a neighboring atom. In this example, okay, here we have helium atom where the helium atom is in neutral condition or neutral situation here. So what happened here? Okay, we put another helium atom, okay, close to the first helium atom, and what happened? Okay, they will form the instantaneous dipole, or what we call induced dipole, okay, on neighboring helium atom. And what happened? It will form a resultant attractive force. Okay, so the partial positive attracted to partial negative, and partial negative attracted to partial positive. So these London forces are actually very weak attractions between non-polar molecules. Okay, so it arises from the interaction of instantaneous dipoles on neighboring molecules. Okay, so here, okay, first one, the electrons in the atom on the left move to the left. Okay, and this second one, when electrons in the atom on the right also move to the left. Okay, so an instantaneous dipole on one molecule can produce an induced dipole on another. Okay, usually induced dipole we refer to the non-polar molecules. So the net interaction of these over time is attractive. So what is temporary or instantaneous dipole and also the induced dipole? First thing is the movement of atoms or molecules, okay, together with their electrons may actually result in the electrons gathering at one side of the molecule. Okay, so for example here we have helium, okay, helium atom, and then this helium atom has temporary dipole. What happened here? The movement of electron from the negative to positive. Okay, so this partial positive is slightly bigger than the partial negative. So this will result in temporary or instantaneous dipole for the molecule. And then other than that, okay, if we have helium, two atom of helium, okay, helium atom 1 and helium atom 2, we put both of these close to each other. Okay, if this molecule is close enough with another molecule, okay, it will start to induce a dipole with its neighboring molecule. And because of due to the random movement, a different temporary dipole is created the next moment, which will induce the dipole from its neighbors. Okay, and here the arrangement keep on changing as the molecules are moving. So for the induced dipole actually depends on the polarizability of atom or molecule. So we have discussed about polarizability in Fahn's rule, where this polarizability has or depends on two factors, okay, which is first is the charge and second one is the size. Okay, Alright, and this polarizability can measure of the ease with which the electron cloud on a particle is distorted or movement of electrons, and this polarizability tends to increase as the electron cloud volume increases, because the larger the electron cloud or the higher the number of electrons, the easier it is to be polarized, and this polarizability also increases with the increase of molar mass. Alright, so large electron clouds are usually more easily deformed than the small ones. Okay, so the magnitude of the resulting partial charge is also larger, and so if we have larger molecules, we'll experience larger London forces than small molecules. Okay, so in this example, we have the boiling point of the halogens and also noble gases. We have halogens and also noble gases as here. Okay, the halogens we are especially for the bromine and also iodine. Okay, they have larger boiling points if we compare to the others. Okay, because all of other than bromine and also iodine, they have negative degree C of boiling point. Okay, so what happened here, because bromine and iodine have larger size if we compare with the others. Okay, alright, then last but not least, okay, the conclusion for this topic, the polarizability actually increases with a greater number of electrons, so it must be related to the size, and more diffuse electron cloud. Okay, and dispersion forces also usually increase with the molar mass. Okay guys, so that's all for this part, the London dispersion forces. So for the London dispersion forces, it is actually related to the polarizability that we have learned in Fahan's rule. So guys, please don't forget to like, comment and also subscribe to my YouTube channel. I will see you guys in the last part of this intermolecular forces soon. Bye!